So this last topic kind of makes me giggle when I think of if you've ever been around little kids that just can't sit still. You're like, oh, dude, can't you sit still? And they're like, no, I can't. Well, these slides kind of show why none of us are ever sitting still. But there's a lot of motion going on, and we're going to see that we're going to hit in chapter 4 the fact that actually this motion has been conserved from a long, I don't know how to explain it, but motion needs to be conserved. Energy needs to be conserved. So anyway, one way that we are all moving, specifically if you are moving if you are at near the equator, you are moving more than if you're at the poles. But when the Earth rotates or spins on its axis of rotation, as shown here, I'm trying to kind of show the axis of rotation. That's a motion. Okay, we call that, of course, rotation, and that's a term we'll talk about later. Not sitting still there. So there are actually several things up here I kind of want to emphasize, to highlight. Now, it's kind of not necessarily has to do with motion, but I do want to point out this first one up here, this right here, the fact that it's a unit of length called an astronomical unit, an AU, astronomical unit, astronomical unit. Okay, and actually 1 AU is the average distance between the sun and the earth. Okay. All right. So what else did I want to say? Oh, we'll be talking more about this, but you probably already know that the Earth's axis of rotation is tilted. It is tilted by 23.5 degrees. And I say you probably already know this, but we'll be talking about that more lately. More later. It's actually why the Earth has seasons. But with regard to motion, here's the thing: is the word is orbit or revolve. They are the same thing. We say that the Earth orbits or revolves about the sun. Okay, that's another motion. That's my point here with this discussion of motion. I'll go ahead and give you a heads up too. We're going to talk more about this in chapter 2, but kind of this. Do you see kind of the box here showing you like a sheet of paper that the Earth orbits the sun? That's called the ecliptic, the plane of the ecliptic. So that's a second motion. Two more motions actually are represented here. These are maybe my favorite. Okay. This little box right here, okay, this would be kind of the stars in the vicinity of the sun. The sun is kind of a little bit, and it's not random, but it is kind of moving up and down a little bit in its region. But the other thing is not random at all. The sun is represented by this kind of a tan-looking circle here. The sun does one of these every, like the slide says, about every 230 million years. The sun, what did I do it the right direction? Yeah, the arrows are going. The sun makes one orbit about I'll put BH here. What's BH stand for? Black hole. All the stars orbit the black hole. It's kind of like if they don't stay moving, then they will fall in. So orbiting is important. So that's two motions, kind of bobbing up and down, shown here, and then orbiting, shown there. So kind of speaking of this motion of all the stars, and we'll be talking more about this later too. Actually, this motion is an indication of mass. Okay, how do you say? You can study the motion of objects and then understand what mass those objects have. And in doing so, what they found out, and I'll kind of do, I'll write halo up here, like and halo down here. Okay, and do you recognize that actually this is looking into like the frisbee. That part I just drew is what we call the disk, okay, of the galaxy. So picture those stars kind of orbiting the, oh, I'll put a BH, what's that stand for? Black hole in the center of that galaxy. And looking at this motion, what they found out was that there is the mass, how do I say this? There is mass hidden in the halo region. I say mass hidden in the halo region because you can't see it. So they ended up calling that just simply dark matter. You can't see it, you know it's there. Why do you know it's there? Because of the motion of the stars. So it's classic. We see that all galaxies have a lot of dark matter in their halo region. What's moving? Okay, motion. Well, Edwin Hubble, I want to say, actually, yep, Hubble, figured out that the galaxies, okay, that galaxies are all moving away from each other, okay, and that the farther away the galaxy is, it's moving faster. Okay, and this is actually consistent with the fact that our universe is expanding. Maybe expanding since the momentum of the original Big Bang. So this idea about the farther away galaxies are, they're moving faster, can kind of be summarized with raisin cake. Now, personally, I've never eaten raisin cake, but there you go. The thing about raisin cake, it makes a good prop because if you picture kind of it before you heat it up, it's kind of nice and all the raisins are close together. Okay, and remember I said that, I think this is quite clever, I said that our galaxy is part of a group of the galaxies called the local cluster. Well, let's make us a local raisin, okay? So let's go ahead and bake for an hour and then see where those raisins are. Remember, raisins are basically going to be galaxies. So what you see if you were here is that, and I'll kind of pull up the table here. What you see is that the raisins at locations 1, 2, 3, okay, locations 1, 2, and 3 actually appear to ultimately have gone increasingly farther from you. So the closer one went at speed of 2 centimeters per hour, the next one 4 centimeters per hour, and the furthest one 6 centimeters per hour. So the point here, similar to galaxies, is it looks like the furthest one away from you is moving the fastest. So that's how that all kind of goes. And so that is consistent with basically the raisin bread expanding, just like our universe is expanding. There you go. It's classic. Okay. So Edwin Hubble discovered that. And we're gonna if you've ever heard of the phenomenon called redshift, actually that is what Edwin Hubble has used, and scientists since him have used to detect this motion. Summary, this kind of just summarizes all the ways that we're moving, okay? Now, I am going to, one of these days here, be preparing your unit exam. It will be in part over this chapter, and this is a classic. I'll have a question or two about how are we always moving. We are on the planet Earth, and the planet rotates on its axis of rotation. The Earth orbits the Sun, the Earth revolves about the Sun, and remember this one right here is actually kind of showing you two motion, kind of the bobbing up and down, and the stars going around the black hole in the center of the galaxy. And then this one right here is showing you the expanding universe. So